Hello. Am I live? Let's see. Looks like I am, but I don't see my stuff. Okay, let me edit the stream stuff because the title is wrong and all that. Um, I'm using a service called Restream, right? And their stuff is weird. Okay, let me try it here. I know I can do blah, blah, blah. Stream information. Now I have to log in. Okay. Let me do this. Okay. All right. All right. I'll be right back. Just getting ready. Okay. All right. Okay, let's get down to business, shall we? So yeah, today we're going to work on Swift System Extras. What is it? It is a file system library built on top of Swift systems. All right, so simple as that. But I'm not working on it from scratch. Okay, I'm porting essentially my other file system library, which I've also worked on a lot on stream before, from many years ago. Pathos, right? So Pathos has a huge amount of API. Here's a little demo here. You can create a path, and then you can create a working, well, you can set it as the working directory temporarily within this block, right? And then you can make temporary directories. You can concatenate path components. You can use glob. You can get the base of the path. I think in this case, it means dropping the suffix. You can make more directories. You can actually create directories with parents, and then you can read files from your path, and you can write files from your path, and you can move things, right? Just for a demo, this is the sort of capabilities you get out of the box, and I think what I really like about it is it works on Windows. So there will be a lot of I think the main challenge from building another library is not the fact that we're basing it with a set of new APIs, but reevaluating the implementation as we go, right? The unsafe APIs has evolved a bunch since I started this project for Swift, and just my general taste and experience might have changed. Who knows, right? That's if I'm doing things right, I should be changing. What else? But yeah, that's probably the source of the speed bump. I have brought up, bootstrapped, if you will, this project to a point where I can do things like this. Let's do a little review, right? I don't know which one. These timestamps are not very helpful. So look, this is the new library, right? Based on Swift system, you can take a file path. Call it standard method, and then create a temporary directory. Within this scope, you get access to this directory, and you can do things like appending things. I guess that's part of Swift system, right? But the point is, now I have enough to write this style of tests, which is very important. What is it? It's really creating this temporary directory, make it available. Underneath the creation, we have to make sure we have write access to it, right? And then at the end, we will clean it up. When this scope is over, we will clean up whatever we did in this directory. So if you think a little bit behind the scenes, that means we are able to recursively iterate over the content of the directory, right? Its child directories and its child directories, etc., etc. We will be able to delete them, right? We'll be able to delete, let's say, a full directory. We'll be able to delete a directory. We'll be able to delete a file. We'll be able to delete a directory that's not empty or empty. And if you do things right, your user would expect, sometimes they want to error when the directory is not empty, and sometimes they don't, right? So right now, this library has all that capacity, but it's still missing a whole bunch of stuff from compared to Pathos, my older library. And so today I'm just trying to close this gap as much as possible. Yeah, that's the goal, right? Anyways, that's enough talking. Let us do something, right? I want to bring up VirtualBox because, like I mentioned earlier, an important thing about this library is it works cross-platform. So we'll have a Windows just stand by. Then we'll bring up our trusty oh, look, I have a branch here. Is it fixed? Oops. Check out main reset origin main. And then let's take a look. I feel like read write would be here, right? And methods for reading and writing. Let's try to rebase it. No op. Okay, so this branch is over. Sip of coffee. All right. So the first thing I want to do is I left myself a little breadcrumb from the last time I worked on it. Evidently 25 days ago, right? So here we implemented, excuse me, it's all me, implemented methods for setting permissions. Okay. So yeah, as you can expect, it's just change mode, right? Change mode, chmod, or some people would pronounce it, and we do it in a cross-platform way. This is a test. Let's make it a little nicer, make it a little bigger for you. And yeah, we like mentioned earlier, we create a temporary directory. In this scope, we write a file. We get its old permission, check that it has owner right, and then we set the new permission with subtracting the owner right, and then we check whether our set method has effect, right? So this tests both the reading and writing of the file permissions. Eventually, we assert that no, we no longer have owner right, right? So everything looks fine. I don't want to. I mean, it's really just a overlay for the different method names and types between the platforms, and things are compiling and running just fine. But test failed, right? Test failed. Why? Well, turns out, yeah, whatever this means, right? I think though, well, anyways, turns out, I already know the underlying reason. The ChangeMod implementation on Windows is just a facade. This thing doesn't work, right? So even though you can write code like this, it's somewhat close to the POSIX standard, right? Compared it to this, it doesn't have any effect, right? As expected, like the permission bits on Windows don't really exist. They have a compatible API for it, but it doesn't really mean anything. I just realized something. Sorry. Before we continue, we need to talk about this. Hold on. What's going on here? Where is my terminal? Okay. This. All right. Sorry about that. Yeah, so the bigger problem is that Windows don't really respect the POSIX permission bits, right? Because it doesn't have all that capability. Like it's linked, yeah, it doesn't have the concept, the one-to-one concept of like groups and others and all that stuff, right? So, so the only thing that they share, I mean, when I say they, it's POSIX and Windows, Unix and Windows, well, the only thing that they do share is one single bit. If you look at the permissions here in my old library, there's a permissions protocol. Okay, it is actually intended to be used as existential or boxed value, as the Swift team newly dubbed. And it has only one property, right? It's read only. And then there are two types that conforms to it. There's POSIX permissions. Okay, and this should look very similar or very familiar to those who are familiar with Swift system. And then there's the Windows attributes, right? Windows attributes has a bunch of other stuff. All right. But among them is whether this file is read only, I believe. Anyways, the point is, we probably want to do something like this, right? Like we probably want to make something like set POSIX permissions and then make it only available on POSIX. That I think makes sense. Let's start with that. So we will check this thing out. All right. We won't throw this work away. Let's, oh, there's a whole bunch of stuff. Let's squash them all. And let's look what happened here. We have a big old test. We have a sample app. Okay, we have this change mode, blah, 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 blah. Oh, really? It's just a little wrapper that calls this. Good, great. Yeah. Permission Swift. How about we just make it macOS only? I think I have a minimal version for some reason or other. Yeah. 12, whatever. And now we also need to make the test reflect this. The bigger problem is I have this metadata method, right? This metadata method returns a file metadata, and file metadata includes this permission, but this is no longer correct, right? The permissions really should be, even though it is cross-platform on Swift systems, maybe we can keep it. Yeah, I was saying, like, even though it is cross-platform on Windows, it doesn't really mean much. Yeah, it was a design discussion that we should have with the maintainer. But yeah, we added this availability stuff. We probably also should rename it a little bit. Instead of calling it set permissions, we should say set POSIX permissions, right? And then at the call side, you would call it set POSIX. It's like a documenting purpose for users so that they don't have the illusion that it works on Windows. Now, if I run Swift test, we're going to compile a bunch of stuff. We have 0 failures. All right, we could wait for this to pass, or we could just test it in our VM. Let's open up a terminal here. Do I have it? Swift system extras. Oh, I don't have a git config. Global user.email is my email. All right. I think, yeah, we're on the right branch. So okay, what will happen here? Long pause. Oh, at least we're building. The typical linker warnings for Windows. I kind of want to hide this. Can I do this? Taskbar settings. Active Windows now. Oh, let's not talk about that. Okay. I have multiple Windows 10 keys, but I do not want to spend time activating a VM, especially when everything else is working. Okay, all tests. Test setting permissions. Permission denied. That's interesting, right? I think that means, oh yeah, available is probably not the same as, yeah, we should do the compiler flag instead. So this is what I really want. OS. All right. Hello? Oh, wait. That's not what I want, actually. Wait, can I do this? I forgot. I never. It's really hard to remember. Okay. Yeah, this is what I want. Okay. All right. That's better. So this should pass now because we're not really, that function doesn't exist for Windows. Should be 11 test, 11 passed. Oh, it's building the sample app. We can take a pick at the sample app. It's building another sample app. It's probably moved on to something else, but the output is not. Oh, there we go. 11 tests. Let's take a look at the sample app, by the way. Think is in here, right? And then I can go to debug, ls exe. Isn't that neat, right? We have a ls, and then yeah, we have the Unix permissions, and I think this is the file size, and this is the file name. Actually, I believe. Yeah, the sample app is there to, I guess, test the metadata APIs, but it also did a bunch of, yeah, it's doing the metadata thing, blah 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 blah. Okay, let's. I think now we can probably merge that thing now. Auto merging enabled. Okay, good. So let's do the real work here. The real problem here is our new type metadata. Let's keep the permissions thing to be compatible with Swift systems, because file permissions, after all, is a cross-platform thing on Swift systems. We'll just document this heavily. Right, say to do document the fact that the on Windows these permissions aren't effective as they are on Linux. Let's just call it Unix. Okay. So the question is, do we want to handle that? Sorry, do we want to handle that shared bit of permissions between Windows and non-Windows, right? At first, I thought I would want to do it, but right now it doesn't feel as urgent, right? So let's just pick something else to do. Documentation, API references. We have the file type, we have the errors. We can work on symlink a bunch. Or we can work on CRUD, all right? Right, we can work on things like making directories. I feel like I should already have it. Let's see. Make. Yeah, I already have make directory, which is here. Ah, it's in this file. Okay, so we have make directory already. We have delete recursively. Make delete. We have copy and move that we can do. And also, I need to add the symlink stuff. Symlink stuff is super complicated on Windows. Yeah, let's start light. So I want to call this maybe a more obvious name. CRUD. I like that. All right. So what I want to do is probably open up Pathos side by side. And then so we have different implementations for Windows and Unix. It's not a big deal. So on Unix is just rename. On Windows, it's move file W. But I wonder if the rename works as well, right? W rename. Does this exist, Windows? Maybe it'll work. See, this is the thing, the sort of thing that I guess I learned really from reading Swift Systems code. Just call it the internals. Just copy this. And then call it. Oh, actually, we can simplify this now. Well, we'll do it in a different. So what do we need to do rename? We need a from and a to, right? From origin. To. Oops. Yep, takes 2 pointers. Got origin, we got target. I like origin and target as opposed to like origin and destination, source, and maybe source. Wait, hold on. Source? Yeah, source is fine too. Because they have the same amount of letters. Okay, so non-Windows, we just assume rename exists, right? I could do like whatever. I could do like can import or something. Okay, so now that we have this, we can simply add a new method in CRUD, right? this being Swift, we're doing the object-oriented style interface. So see, I have things like this, but on Swift system we have with platform strings. And then we got the C string, source C string, and we got another C string. Call it target C string. Now we have both C string. We simply just call if system rename source C string, target C string. If this ain't 0, something is wrong, and we just throw it away. System error code error. Okay, and that's that. Let's write a little test for it. Let's call it CRUD tests. CRUD. Sounds like a name of some rough characters. Okay. CRUD tests. It's a XA test case. And let's test simple move. What do we test? We have the file path. We will do with temporary directory, and inside we have the temp folder. We can now write a little file. Let's see if I can remember things. Let a path be the temp appending a. See, if this is pathos, I wouldn't like. I need to remember things like temp.appending, but pathos, I definitely could just write this or join with or something like that. But different conventions. Okay, so we have A and B. These are just path values. Now we need to create a file named A, right? So A path, we can do write, I believe UTF-8 string, something like hello. Is this how you do it? No. Then it must be this. No. Okay. I am stumped. We've seen at least one of these before, right? Is it metadata? It's permissions. Right? UTF-8. Ah, yeah, of course. String is redundant. Duh. Okay. All right. So this is our setup, right? And then before we move on, let's assert a few things. We can assert that A exists. Okay. Question. Does exist? That exist does not throw. And we can assert that B does not exist. Okay. And then the main event is we'll do call A path.move to B path. We'll throw if necessary. And then we will assert that A, oh wait, this is move. So wait, this is false, right? And then we'll flip the condition. This will be false and that will be true, so that A is no more and B now exists. Step number 1. Step number 2, read, content is bpass.read UTF-8 string, I assume. We have to assert that the content is the same as, well, we'd have to do the expected content is this. Expected content. Okay. What are the chances, right, that this test just works? Very low. Test, simple move. Yeah. That makes sense. Let me fix the internal ones. Let's make it conventional, right? Like, make it look like an POSIX API, no labels. We write C. Here. All right. So that's problem number 1. Error is not fine. We need to probably import something there. Not a big deal. CRUD. Okay. Hey. Hey, Mike. All right. What is that about? Can't find earner. Oh, system error, I guess. Yeah, earner is the real one. The system error is the wrapped one from Swift Systems. All right, let's try that again. It's not called system error. It's called error, I think, from, again, Swift Systems. And we have to use raw value. Okay, got it. Cannot find file path. No problemo. Import system package. All right. Woo. Oh, more errors. Of course, this can fail. No problem. Pending. Am I? Huh? Oh, I can't spell. Okay. More errors. Of course, all of these things can fail, so let's not be presumptuous. Read. So there's a write, and somewhere there's a read. Here. Okay, we have one test. It passed. Freaking amazing, right? We changed a bunch of stuffs. Let's review. So I think I moved this file to CRUD. I added this, added a comment, and it's all Gucci. I'm gonna stash this change, switch back to main. I'm gonna use the shiny new thing called git head PR. No, let's just do this, right? implement file path move to. And then we will submit PR. Now we have a draft PR. Yeah, mainly I just want to find out how well it fares on Windows. So let's just fetch origin. Let's copy implement file path move -2. Okay. It's building. And it works. Great. So that's the first test. I'd rather call it simple move. Let's call it move file, right? And the next test, we will move a directory. How about the empty directory? And what do we need to change? A is now a directory. We still assert the existence of them. And then we move A to B. We check the existence. But we will also check that bpath.metadata is directory. Is that how I do it? Let me think. Let's take a look at metadata. Metadata returns a metadata. Metadata has a file type. This makes me think that metadata could use a few shortcut convenience methods. But for now, let's run the tests. Test passed. Okay. And then all right, so the AB naming is not working anymore, right? So let's call it a path, a directory path, and then B path is now B directory path. And then we have the directory path. We have to do, so this test I want to move the directory, but also the directory will have some files in it, right? Let's do say C in a path is a directory path appending C. And B path is the B directory appending C. Okay, so we have a whole bunch of stuff to set up. Now we have to create the A directory. We have to also create C in A, but it's gonna be something like this. So we'll have to have our trusty expected content here. Oops. And then something like this. We make the directory. We write the file to, oh, not here, not here. Here. We'll try to write the file to C in a path. Probably copied. Wait, where's my expected content? Oh, it's here. All right. So now we have to assert that A exists and C in A exists. And B does not exist, right? And then we do the move. We move the A directory to B directory. And then we assert that A does not exist anymore. And then we also have to assert that A in B path. C in A path. Did I make that mistake earlier? C in A path, right. C in A path does not exist. And B now exists and C in B path exists. So we moved A to B, so A shouldn't exist. Its content C should also become non-existent. And we have to steal the content comparison here. The content is now C in B path. Read a string. And then we compare. All right, what did I do wrong? Nothing, apparently. Just pass. Just works. Update PR. Okay. That's a whole API done. Apparently, the thing that's still missing is documentation. I'll address that separately, right? So this is just a move. It's almost better to separate the tests at least. Call it move tests. Move tests. That's fine. I like that. Whoa. Okay. All right. So we can merge this and move on to the next task. I think I have a delete already. Yeah, we have delete, we have move, we have make directory, I believe. Yeah. So I guess we don't really have update. What does it mean to update a file system? Delete is working, make directory is working. Updating is like writing to this content or something like that, right? Oh, this is interesting. Oh my god, I forgot about that. Okay. Yeah, home directory. Does Swift system have anything like that? Yeah. Swift systems documentation. I'm guessing not. Yeah, because to find the home directory is actually a what do we call it? Something synaptics, systemic APIs. I don't know. Swift systems roadmap. API roadmap. All right, let's see what our friend Mako has to say about the future. Keyword home. I think there's something about homes, but move only, file type, process type, pthread, exit, add exit. Yeah, process stuff, pipes. Syntactic, that's the word I was looking for. Dupe. Oh yeah, we should have a copy method. Copy. We could do this. And because we don't have symlinks, things are actually much easier, right? Because if I open up path plus Windows, I bet there's a separate implementation of copy here. Yup. Man, Symlink gives me pause. I have many hours of working on Symlinks on stream in the past, and it was a struggle. And it required a lot of stamina to actually push it through. Ugh. But eventually we'll have to do it, right? Because the file system API without Symlink support everywhere is not really very practical. For example, if you're building an iOS app with Bazel, in Bazel everything is symlinked, right? So if you try to read a file or move a file around, actually just read a file, simple things like that, that just won't work. You'll read the content of a symlink as opposed to the linked files of the symlink. Well. Yeah, I'm building up the courage, right, to eventually start working on Symlink. But let me take a peek at copy. So copy, it's pretty long, right? So what we need to do, we get the source metadata. We're gonna make sure that, okay, so we can copy symlink on Windows. And let's just read the POSIX one. Wait, why is this? We also are making sure that the source is not a symlink. That's weird. Is this a bug? If the source meta is not a file and is not a symlink, So we're actually just copying the files here instead of, if it's a directory, we won't copy it. That's It's not what I remembered. So we take the C strings and then we read. We get the file ID, the destination file ID, and then we make a buffer with chunks, and then we also have to copy the permission bits. Makes sense. We read the chunk and write it to the destination. Huh. That's surprising. I guess it's not what I remembered. Oh, something's wrong here. Two failures. Directory not empty. Aha. Guess on Windows you can't just rename things. Interesting. That's totally fine, by the way. Wait, it works fine here. Am I not looking at the same branch? Implement file path move to. Hmm. Faulting test, two failures. Directory not empty. Wait, two failures. What? But there's no... So on the Windows here, on the Windows remote, it fails, but locally it works? What is that about? Yep, here it is, test move directory. Passed. Test move empty directory. Passed. But here we got 2 failures. Okay. I mean, the contingency here is this. Like move file W should work. Yeah. Key, we're installing Swift. You cannot use rename to move a directory. Directory can only be renamed, not moved. Aha. There it is. But how come it works locally here? That's sus. Okay. Just Microsoft things, I guess. You cannot use rename to move directory. Directory can be renamed but not moved. Okay, so this makes me wonder. I mean, we can easily fix that. But the question is, if I use the Windows API, that does work, right? Well, the error handling work out of the box. No. Swift system. Oh. Let's get a copy of this. Oh wait, I know, I already have a copy of it. It's in the Swift folder. Forgot. Syscalls. error number. System error number. Okay, it's using the UCRT get error number. So let's read that, because on Windows there's also get last error, I think. Let's Google it. So there's this and get last error, I think. Are they interchangeable? There's no relationship. Oh no. There's the C runtime library errors and then the Windows API library. Almost all the APIs there's a returns error and colors will indicate in some way when error occurs. And says call get last error. So I'm assuming this library just don't have a call to get last error ever, right? Oh, it does. Map Windows error to error number. Thank you. We need to do that. A lot. Yeah. I guess for now we can do the same thing as this, right? We know there's error and then we just use a generic error code. Okay, let's take a look at move file W. It returns a boolean apparently. So I guess instead of doing this, we can simply do, if the OS is Windows, we do something and then else and then and if, right? And then here we can just call rename. And here is a totally different thing where we do if move file W. Right, so something is wrong here. So we will discard the get last error, and then we will throw to do map Windows, all right, let's call it when API error to error no when Swift systems does Okay, so we just throw a generic error here, and does this even compile? Let's read carefully, right? We move the file, we have the source string, the target string, we check the return value, which is a bool. And then if it's not successful, we read the error to clear it from the last error. We throw a generic thingy. And of course, the syntax here is wrong. Don't panic. Other than that, actually, it takes a cint. I think it's fine. Cint is just some alias for integers. So I use a integer literal should be fine. Okay. All right. What do I call? Update PR. Now we will pull that change here on Windows and run the tests. Run the tests. That's an unexpected speed bump. And I can't do this because I didn't import enough stuff. Stuff like Win SDK, right? If Windows I wonder how many Swift programmers know that you can import this. This thing even exists inside the... I guess it's technically part of the standard library. I mean, it's shipped with the compiler. Not part of the standard library, obviously. Okay. Now we get rid of the compiler complaints. And we're compiling. I'm like narrating like a sports. Oh. We're compiling the tests, and all the tests passed again, but that's meaningless because last time all the tests passed in my VM as well. But for some reason, the GitHub VM didn't like it. And we're still installing Swift. Okay, that's fine. I'll just work on something else. Right. The surprising thing is I discovered, to my surprise, that my old function, library function, does file copy but not directory copy, right? I assume that means copying directory is incredibly complex. So in this new version, I would rather call it copy file, right? To destination file path. Yeah, I'm still working on my courage of adding Symlink support for everything. It's a huge task. And also critical for 1.0. Okay, the test is running. I am dying to find out. Oh, it's building, I guess. Oh, they failed again. I wonder why. I know, I mean, the Y is gonna be not very good because the error code is. What? Move either a file or directory, including its children, will fill when the directory is on a different volume. What in the world? If Windows, we should be calling this, right? Oh yeah, I can delete these. Let me do that. Internals. I can delete it or I can wrap it. Let me think. The advantage of wrapping it is I already import a bunch of stuff here. So I can just import when SDK, right? And then in here, I can just copy over the implementation. And then back in CRUD, I can remove some of these and some of these. Okay. Okay, good. It's really confusing though. Like what really confused me is how we get a specific error that says the directory is not empty, even though if something went wrong, we should get -1. We shouldn't be that specific. So that's really suspicious. Okay. You know what? Everything starts with a small step, right? I should work on after we make copy file, we will work on read and write symlinks. Once we have that, I think things will feel lighter in terms of adding symlink into everything else. This task is always the slowest because we have to install Swift every time. Would be nice if GitHub Windows VM Germany will restart coal-fired power plants in order to conserve natural gas, the country's economy minister announced. The move comes amid concerns about a looming supply shortage after Russia cut gas deliveries to Europe. Would be nice if you still have those nuclear power plants, wouldn't it? Okay, so this thing is just not happy about what? What is it now? How is this possible? Is it actually running the code I wanted to run? No. Open. File changed. So we're calling system rename. Right? And system rename on Windows is this. Hmm. I'm gonna well, I'm gonna make GitHub prove to me that it is running the right version of code, because this is so suspicious. Is -1 happen to be directory not empty? Windows error code. Oh, -1 is not even defined. There's apparently a tool for just looking up the error code. Is I wonder if they use tools complement to wrap errors. Maybe not. Okay. What if I add a syntax error here? We will still build here. No. Okay, let's make some subtle things. So if I add a print statement and run tests, I should be able to see the print statement, right? Yep. Okay. Update PR. Okay. Let me also check the CI implementation and make sure the Windows, well, the Windows thing is doing the right thing. So we're installing 561. We could try 562. I feel like 562 is out, right? For Windows specifically though, 562, Windows 10, yeah. I can try 562 and see if anything changes. Because something definitely feels fishy. Fishy AF. Okay, let me work on the next thing. Well, I kind of don't want to work on the next thing because this is bothering me so much. Okay, I need to learn the cache stuff. Let's see. GitHub Actions cache. Cache dependencies and build outputs. Use this action. Usage. Create a workflow in your example workflow is available below. Inputs, path, blah, blah, cache hits, okay. Caching primes, matching a caching key. So if the cache hit is false, you do the work. Otherwise, what is this? Swift package manager, SPM hash files. Uses cache v3. Right. $10 gigabytes of cache. Cache numbers uses cache v3, path numbers, key primes. Yeah, I kind of want to play with this because it seems like it's simple enough. I need to know what install Swift thingy does, right? GitHub Actions setup Swift at main. And then we can add an if condition here, right? We can do if steps cache primes. Right. So there's a step named cache primes, right? So later is referred here as steps.cacheprimes. And then it has an output. Cache hit. So the key is somewhat locked with that's fine actually. I can lock it with my log file as well. It sort of makes sense. Yeah, the real question is like, does it exceed the 10 gigabit limit and all that? Okay, so I'm assuming it's filling again, but this time we can take a look at a log and see if anything fishy is happening, right? Go towards the end. No, nothing fishy is happening. I'm not seeing the output from the... I'm so confused. One, I have no idea why it's failing when it works just fine on my VM. Two, I have no idea how it got this error in particular, because all I'm doing is returning -1. Actually, let me play with... I want to play with the cache for now, because you know I kind of ran out of idea with the actual task. Matching a cache key. The cache action first searches for cache hits for key and restore keys in the branch containing the workflow. If there's no hits in the current branch, the cache action searches for key and restore key in the parent branch and upstream branches. Restore key allows you to specify a list of alternative resource keys to use blah blah blah. npm feature something something key restore key. So this is them doing the npm caches, right? So they're caching the node modules. They make a cache name. Restrictions for access your cache. The cache created on the default branch will be accessible for any pull request if the feature B has the base branch feature A. B would have access to cache created on default branch. Access restriction provide cache isolation, security, blah 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 blah. Inputs. A list of files, directories, and wildcard matches to cache and restore. See action glob for supported patterns. For me, I would want to cache everything inside this folder, essentially, right? Or even everything inside this folder. A key for restoring and saving the cache. For me, the key would be something like, ideally it's a static thing that's just a Swift version, right? Restore key. An ordered list of keys used for restoring stale cache if no cache hit occurred. Okay, outputs, cache hits. A Boolean indicate an exact match was found. All right, so here is the input, right? They have a path, and then they have prime. They have the key. Okay, let's try this. Cache Swift installation. The path is this, hopefully. Hopefully this will work. The key is the Swift version. Let's call it wait, how do you do an environment variable? Like this. Okay, so if you have a job, you can define environment variables like this, right? So let's call it Swift release colon like so. And then here we can do env dot Swift release. Hopefully the tag is the same. Okay, and then our cache key will be also env dot Swift release. So we have our path, we have our key. And now we can check the cache hit, right? If cache Swift installation is not true, we will do this. How about that? Cache Swift installation. Okay, and then oh, let's do it. Okay, so let's see how this works. Cache not found for input key. Perfect. So now we're installing stuff. I mean, this will pass, so I'll just merge it, right? Oh, install Swift. The file or directory is corrupted and unreachable. Huh? I'll do the checkout after the installation. How about that? Okay. Yeah, I remember playing with this stuff some years ago. Some time ago. I don't know, years is correct. Probably the last time I updated the CI for Pathos in any significant way. So a few years ago. And I remember giving up. So, obviously, I didn't figure out how it works. This command cannot be run because working directory is corrupted and unreachable. So checking the cache somehow corrupted it. Okay, so now we're doing check the cache and then check out and then do this. So we just essentially added checking cache at the first step and everything else moved downward. Install binary URL name argument list. Also, I can use checkout v3 apparently. I wonder if that makes a difference. Okay. Install Swift seems to be doing something now. Installer.exe. Nope. Still bad. Okay. Let's try the install v3 thingy. It has something to do with the particular implementation of the install Swift step, I assume. Well, I give up. So I'll just drop everything here. Reset, hard. Okay, let's keep investigating the move stuff. Internals, right? Instead of printing stuff here, let's print some stuff here. Oh, the unfortunate thing about doing real work is there's a lot of downtimes like this. I mean, ideally, yeah, you optimize your workflow so that other stuff happens. So let's try that, right? Let's make another commit. CRUD. Let's write our copy file thingy. You know what? I want to read about things like read symlink. Okay, so on Windows, intense Windows C wackiness. Oh no, see? This huge paragraph is why I'm scared of working with Windows, oh, I remember this stuff. Oh. Oh my god, let's tweet it. Let's tweet this. Let's share our pain. All right. Symlink. What? Path plus Windows. Returns multiple type of structs depending on which one you ask for via one of these parameters. This returns a buffer. And then because this guy's from Exhausted Place, we include a copy of it as part of this project. First of all, as union member, two of these union member, each option being the struct with different content. We include a copy of the tell the size of blah, include the flexible member, skip the first one. Oh my god. Oh, I rediscovered this gem about on how to read a symlink on Windows. You fought honorably past Daniel. Okay. That's a good little multitasking. Where are my failed tests? See, this is why I'm so confused. Where is my print statement? Oh, I know why. I think the error came from this. If it's directory, if it's recursive. So it's hard to believe though, because I am asking for recursive, right? Delete recursive. So if it's a directory and recursive, we visit the child and delete them recursively. Huh. I'm gonna print all of this before everything. Okay, so I assume that's where the error actually got thrown. That finally made sense. Okay, I need to get used to this stuff, so let's use it again. All right, progress. Slow progress. Maybe we can try to get rid of these warnings from Swift systems. Yeah, so instead of working on this top level library, we can work on Swift system itself. Okay, so let's read about those errors here. So right before we saw this, we were trying to delete B. And also here, we were trying to delete C. Wait, what? We're trying to delete C, right? And what is C? C is move tests. This is in particular test move directory. Move directory. C should be a file. I want to print here. Everything went well before temp. Well, in temporary directory. Let's add this. So I'm assuming everything to this point actually works just fine, all right? And then we start to delete the temporary directory. Let's think about this. The temporary directory at this point contains B and C, which we saw right. At the end, we want to delete the temporary directory recursively, which means we need to first go in and delete its children. So let me print self here. All right, this lack of progress is really demotivating. Hmm. I mean, the weirdest thing is, of course, everything kept working in my virtual machine, right? It only fails on the on GitHub Action. Everything went for in temporary directory, and then you try to delete this temporary directory, which asks you to delete B, and then in turn you want to delete C, right? Everything. This is what I expect to happen, and then it succeeds, right? That's how it's supposed to go. For some reason, when running in GitHub VM, things don't go that way. So let's read. First weird thing is we're not trying to delete this for some reason. That's really weird. Right? Ooh, sorry. If you compare this log with my local log, the local log always start with this root directory. And then, of course, it has a child. We'll try to delete that. And then this. But here, we don't try to delete the root directory at all. That's strange. So how is this a... How do we... What is causing that? Oh, wait. And also, we didn't do this. So one of these steps actually failed. So is this actually this? Before move, after move. This is so frustrating because everything works locally, so we have to debug on CI. This is hell. Anyways, if you're watching this, thanks for watching, and please consider leaving me a like or something like that. Give me a follow. Depends on where you're watching it. Chances are you're watching on YouTube, though. Boop, boop, boop. Okay. Yeah, I was going to implement read symlink, and then I run into this monstrous. It doesn't look like it's a lot of code here, but it's Definitely a lot of comments here, right? There's some like math, pointer math. There's more pointer math. Looks like we're calculating the byte offsets with something called a name length. Name length is, of course, more math. Oh my god. Luckily, the CI is fairly fast. Let me see. Installing Swift only take 1 minute. Okay. Before move, after move, everything went well in temporary directory. Wait. So we try to delete this, delete this, delete this, and then we saw an error. All right, let's add more. Temporary. So, yeah, temporary. We know we've called delete, right? We have called delete. So I bet it has something to do with this. It's like the file somehow is categorized as a directory. It has to be this, right? Like C is supposed to be a file, but we are trying to delete it as a directory, I'm assuming. Trying to delete a directory. All right. While that's happening, let's keep chewing on this. So it looks like we read a bunch of bytes from device I/O control, and then we have to cast this buffer to a reparse data buffer, right? And then from this reparse data, we calculate the name length. It has a value called symlink. It has another value called reparse tag mount point. Depending on which one it is, we have to deduce 4 bytes from this thing's size. So for both of this data structure, the first 4 bytes has something other than the name. We divide it by 2, presumably because the data is the word length is twice is 16 bits, and then we have the name starting point. Finally, we cast again to the big word data point of the entire data structure. And then, I see. So because eventually we need to do this. Yeah, so essentially we have a byte buffer and we need to figure out the range inside the byte buffer that's interesting for us. And then we have to take the byte. Yeah. Take the not byte, the words from it. Oh, that's exhausting. Okay. Okay, here we go. Everything while in temporary directory. We go, this is true, this is true, this is false. Trying to delete this. And then we try to delete this. Oh, this has something to do with Windows file system being asynchronous and some stuff like that. Delete. Let me see. Func delete. delete. Oops. Yeah. So the actual way to delete the files is actually you move the file to a temporary place. See? Oh my God. Okay, it all makes sense now. So if you just delete, try naively, Windows will lag behind, essentially. So what the actual way to delete it is you move it to a temporary directory. Let me see what temporary name even is. Temporary name. Oh yeah, of course. It's just the default directory plus name. Okay. Okay. All right. I guess. Right. So this is just not the right thing to do, right? The right thing to do is let's just grab this. Actually, just this. File path. Let temporary temp name equal this. All right, let's write some documentation as well. On Windows, we can't simply rely on the OS to think all children have been deleted at this point. The only way to make it work is to move the directory to another location first to convince the OS is okay. All right, so we want to move from here to here. Actually, we can do it easier. Move to temp name. Let's call it temp location. With C with platform string temp C string in. Okay. Of course, it's not joined, it's appending. Ah. So the test would still pass. Oh, never mind. Doesn't pass. Okay, so something is obviously wrong. What is obviously wrong? No such file or directory. Oh, Yeah, of course. Obviously wrong, like I said. This is no longer necessary, is it? Yeah, it's no longer necessary. So I don't need to open up that anymore. So we generate a temporary location, we move ourselves to the location, and then we attempt to delete the location. Beautiful. With that, I'm tempted to delete all the debug logs, but yeah, this should solve our problem finally. It just took me to 2 hours to remember what Windows actually does here. Should have just read the code. Okay, let's prepare for that. Print, let's get rid of all of this, right? Not here though. Print sources. That's the first one, that's the second one. Is that it? Okay. Oh, I need to disable auto merge here. Just in case we passed the tests. Okay. So there's a whole bunch of stuff about symlinks. Starting with whether something is a symlink, right? Yeah, I have to say my old library is really good. There's so much research that went into it. And of course, I can't help but agree with a lot of its design, right? For example, the fact that the metadata here can be created from a find data handle, right? And you get all kinds of times, file sizes, you get your directory, symlink, file attributes. Yeah, it's so good. Is directory, is symlink, is file. So right now, we do have a file type thingy, but the file type is parsed from the mode, the ST mode from stat, right? So I highly doubt that Symlink would just work with that. Yay, as predicted, our Windows changes. Test finally passed. So update pull request one last time, and then we can finally merge this. Only took us 15 tries. Okay. And that is how you implement Move on all the platforms. Okay. You know what? That's a good stream. I'm gonna take a break from this point on. Thanks for watching.